Today's video is about graphing exponential and logarithmic functions. We're starting off with this exponential here. It is a y equals 3 to the x function. And much like other functions that we've done, if we don't understand what's going on, we could just substitute some values in. So we could consider a little table of values. We have x and y, and think about some values that you could substitute in. And this is, by the way, y equals 3 to the power of x. Now, if we say we inputted 0, we'd have 3 to the 0th power. Well, 3 to the 0th power is 1, because anything to the 0th power is 1. If we put 1 as the exponent, 3 to the first power is 3. If we put 2 as the exponent, 3 to the second power is 9. And if we put 3 as the exponent, we get a y value of 27, because it'd be 3 to the third, or 3 times 3 times 3. Now we could do some negative values for x. If we had x being negative 1, 3 to the negative first power is 1/3. Negative second power, 3 to the negative second power is the reciprocal of 3 to the second power, which is 1/9. Well, we could just plot these few values here. You get a negative 1, 1/3. Negative 2, negative 1, sorry, not negative 1/9, positive 1/9. Negative 2, positive 1/9. Negative 1, 1/3. Both those values are greater than 0. We have the point 0, 0.13. We have the point 2, 9. This gives us the trend of what our exponential function looks like here. This is going to keep growing and growing as we go to the right faster and faster. And then when we consider the behavior going to the left, we keep getting these bigger and bigger negative exponents. So these exponents that are more negative, something like 3 to the negative 8th, which would be when x is negative 8, would give us something like 1/3 to the 8th. Now, I don't know what that is, but I know that that is really incredibly small. It's getting close to 0. And as you keep getting more and more negative powers to 3, it's going to keep making the values even closer. What happens here is we have a horizontal asymptote, a horizontal asymptote at y equals 0. So at y equals 0, we have a horizontal asymptote. That's what we're going to be approaching with that function 3 to the power of x, as x becomes really negative. Now, these exponential functions have some critical points. They always have a horizontal asymptote. The things I typically check for are, as like a shortcut when I don't want to actually substitute in every single value, I look for when the exponent is 0 and when the exponent is 1. And here the x was the exponent by itself. So 3 to the 0, whenever we get something to the 0th power, we know that's going to be 1. So that part is going to be easy to find. We also know when you put something in the first, it's just it itself. So I would always plot these 2 points, considering when the exponent was 0, when the exponent was 1, and also know where the horizontal asymptote is. And the horizontal asymptote exists because the value of this function must stay greater than 0 no matter what. No matter how many times you divide by 3, it's not going to all of a sudden become a negative number. Now, if we consider a log function, consider our graphing of that, we're going to make another table. I'm going to put x and y equals log base 3 of x. And when I input values in here, I can't just input like -7 because, or -9 even, because log base 3 of -9 does not exist because the argument of a log cannot be negative. And that's because the result of an exponential can't be negative down here. We can't have things like this in a non-transformed exponential function. So this is something that's not possible. We have a domain for this that does not allow us to input negative values. But what makes the most sense to input would be values like these ones here. Because if you input 1/9 into x and you have log base 3 of 1/9, the exponent that takes you from 3 to 1/9 is -2. The exponent that takes you from 3 to 1/3 is -1. From 3 to 1 is the exponent of 0. I probably could have put 27 3 because log base 3 of 27 is the power that it takes to go from 3 to become 27, which is 3. But between these two tables, you should notice that the x and the y values are just reversed, which means that these two functions are inverses of each other. Now, we could plot every single point here, but I look at these two critical values. I think about what input would make the argument of the log 1. Well, the argument that would be when x is 1 because log base 3 of 1 is 0. So I have 1, 0 as a point here. And then I also think about what would make that argument the same as the base. In this case, log base 3 of 3 is 1. We could keep plotting all of these points. We could get all of them. Gosh, these ones are a little difficult to do because we keep getting these values that are closer and closer to 0. Ignore this little bump out here. But just like the exponential function had a horizontal asymptote, there's a vertical asymptote at y equals 0 here. Sorry, pardon me, x equals 0 here. X equals 0 is a vertical line. At x equals 0, there's a vertical asymptote because that's the first value that x can't be. X, the argument for a log, must be positive. Log base 3 of 0 does not exist because this is the value right here that you would need to take 3 to some power to get 0. 3 to some power never becomes 0. So that's why log base 3 of 0 does not exist. If we wanted to go more often, we're going to graph functions similar to this, where we have some transformations going on. I'm always looking for a few things. First of all, I'm looking for the transformations that's happening. This here, we have x minus 3. Whenever you put x minus 3, it's going to give you a horizontal shift. This here is shifting the function to the right 3. This plus 5 on the outside is shifting the entire function up 5. And then this negative here is going to give us a vertical reflection. Now, we don't have to just think directly about all of those things to graph this, but I think it's very helpful. What I tend to do is I look for when that exponent would be 0 and what values of that exponent would be 1. Well, the exponent would be 0 when x is 3. The exponent would be 1 when x is 4. And we go calculate what would the value of this entire function be at x equals 3. Well, this would be -2 to the 0th power plus 5. Well, 2 to the 0th is 1. -1 plus 5 is 4. So I have a 0.34. When I input 4, I would have -2 to the 1st plus 5, or -2 plus 5, which is 3. So 4, 3 is this point right here. And the other thing I would really want to think about is the horizontal asymptote, because exponential functions have horizontal asymptotes. Well, this horizontal asymptote was shifted up 5. So that means that one of the two directions, the function is approaching this horizontal line. Well, as you can tell here, this point is closer to that axis than this is, or closer than that, closer to that horizontal line than this is. So it's going to keep going closer and closer to y equals 5 going to the left. And then this one particularly, you probably could have found more exact points. However, you have enough here to go ahead and draw the theme for this, um, this exponential function. Now on this log function, I can't have the argument of this log be 0, just like in the other situation above with the log base 3 of x. So I cannot have x equals -5. X equals -5, that is a vertical asymptote, because we can't have x equaling -5. Then I would go ahead and consider the values that make this both 1 and the base itself. Well, the x value that makes that argument 1 is -4. -4 plus 5 is 1. Log base 4 of 1 is 0. Minus 3. So -4, -3. And then I would also check x being -1, because -1 would give us log base 4 of 4 minus 3. Log base 4 of 4 is 1, minus 3 is 2, or sorry, is -2. So 1, -2 would be this here. Now, as we're going towards this vertical asymptote, you're either going to go down or you're going to go up. Well, it doesn't make any sense to go up. The function was decreasing here. And in this particular one, we probably could have found more points. We probably could have found 9, 1. However, you had enough to create this trend. Now, there's some transformations on this one as well. This was shifted when it's x plus 5. It was shifted to the left 5. We were shifted down 3 from this portion right here. There was no vertical stretch on this because we didn't have, like, say, a 7 here. If we did have a 7, that would vertically stretch it 7 times as much, and it would give us some different y values. But those are the types of things that we could have and we could see.